Hey there. So we have Unit 1, Lesson 13, Incorporating Rotations. So our learning goal is let's draw some transformations. All right, so our warm-up, 13.1, left to right. So we have the semaphore alphabet. Curious what that is. I'm going to look that up later and figure that. Oh, it's for flags. Okay, so the semaphore alphabet is a way to use flags to signal messages. Here's how using the signal the letters J and Z. Okay. For each, precisely describe the rotation that would take the left-hand flag. Okay. So it looks like it's labeled L for left and R for right. Okay. So precisely describe a rotation that would take the left-hand flag to the right-hand flag. All right, let's try to keep in mind we don't want to break this person's shoulders. What do you guys think? For the left hand, where do we need to rotate your hand in order to get it over here? Now, there's several ways we could do this, right? I mean, what do you think the easiest way is? So let's do this in perspective of looking at the person, not the person holding the flag. I would say, let's see. I would rotate the left hand, right? The designated left hand. What do you think? Around, doesn't look like a full 90 degrees. Clockwise. All right, clockwise is the way a clock moves, right? 45 degrees. Is there another way I could have done this? Could I have gone the other way around? Right? So what's the other way around? Way counterclockwise. Okay. How many degrees would that be? I'm going to put that one to you. Definitely more than 270? Definitely more than that. Okay. So I'll leave that up to you to figure out if you went the other way around. All right. In fact, if you actually watch the video and you listen to me, if you answer this and you email me the answer, you get extra credit, flat out. Okay. Because that's some deep thinking right there. It's good. All right. Jay. Let's see. Looks like a 90 degrees. All right. Holding the right hand up and left hand out to the left. What do you guys think? A counter. So rotate the left hand counter clockwise, which is, again, the opposite of a clock direction, about 90 degrees. All right, I'm saying about because I'm not 100% sure or guaranteed that this person's hand are perfectly at a certain angle, but it looks about around that, okay? There is some guesstimation here because it's not exact for this person's hand orientation. All right, now if you did it another way, all right, if you moved the left hand the other way, clockwise, how many degrees would that be? Would that be? So again, if you email me back those two answers of how many degrees the other way around, um, good for you. Get extra credit. No questions asked. All right, activity 13.2, churning on a grid. Ooh, okay, so we're going to use a tool to rotate this parallelogram A, B, C, D 90 degrees clockwise around Q. Okay, so let's try that. Okay, so we got A, B, C, and D. The center of rotation is going to be right here. And they said 90 degrees, right? So 90. All right, there we go, 90 degrees. So it's kind of like the person holding the two signs, right? You have the right hand flag up and left hand over here, and that was 90 degrees. All right, rotate ABC 180 degrees around R. So where on this area do you think, on this grid, do you think the triangle will be now? So we're going to have to go, and it says rotate 100 degrees around R. Notice how it doesn't say clockwise or counterclockwise. Why is that? All right, because if you go 180 degrees clockwise, is that the same as going 180 degrees counterclockwise? Maybe that's why they left out clockwise versus counterclockwise. Because in the end, it's a full circle, right? You just go right back where you were, right? I don't want to go around the topic, but I just did, pun intended. All right, so let's do this. It doesn't matter, right? Whether we go counterclockwise or clockwise. Center around R, and we're going with 180. There you go. So as you can see, it rotated either this way, or it could also rotate around this way. All right. Use the tool below, so we're using this one, to rotate this sock-looking like figure 120 degrees clockwise around O. So clockwise, that's clockwise to the right, right? We got this figure here. There we go. The center around O. And they said 120 degrees. Let's do that. Oh, there we go. 120 degrees. It's strange because it looks like a reflection too, right? Like if you think about it, right? Almost looks like it. That's interesting. All right, rotate the sock looking like figure 6 degrees counterclockwise. Ooh, we're going this way. So we're going to the left, right? Rotating around to the left. Reverse of a clock. All right, so here's our figure that we wanted to transform. Our center is around P, and they said 60 degrees. There we go. As you can see, it almost looks like a boomerang flying, right? Cool. And that was it. That was that. So, what are your takeaways? Does the center of rotation matter? What do you notice about the figures between the centers of rotation? Did the distance change at all from like here's this figure to O, here's the new image to O. Did the distance change at all from the center of rotation? And that's a good thing to notice right now. So activity 13.3, translate, rotate, and reflect. Looks like we may be dealing with all three options here. So we have this kid who suspects triangle ABC is congruent to triangle DEF. She thinks these steps will work to show the rigid transformation of from ABC to DEF. Oh, okay. So ABC, and she's trying to move it over here to become DEF. She says translate by a directed line segment V. Let's try that. So translation button. Here's the original triangle that she wanted. Her vector was from A to D. Okay, so that was her first step. So far looks okay. I feel like that point's a little off. I don't know. I may have just messed up. Who knows? Let's find out. Rotate the image blank degrees counterclockwise around point D. Ooh. Notice how they don't give us the degree. Let's figure it out. They said clockwise, right? That's clockwise. This is the image that we're working with. The center of rotation is on D. It's at 60 right now. Doesn't look good enough. Let's try 80. Oh, nowhere near enough, right? Well, so what do we think? What about something more? 100 and let's try 180. Ooh, I don't know. I don't know. I don't think that's gonna. Work. Oh wait, do you guys notice our third step's a reflection over DE? Oh, what if I line up with DE? So 180 is too much. Let's try something smaller. 120, perhaps. I did it. Okay, because she wants to do a reflection over DE. Okay, so let's do a reflection. Here's the image that we're trying to reflect over to land perfectly on triangle DEF. She says to reflect across DE. You guys see that? If you reflect across DE, lands perfectly. Okay, so it looks like it works, and our angle of rotation was 120. Now, don't get me wrong. Could May have done different sequences to get the same result? Sure, right? Angle rotation was 120 degrees, right? So there you go, mapped on perfectly. So in summary, incorporating rotations, three rigid motions are reflect, translate, and rotate. That means they preserve distance, they preserve length, um, and they also preserve number of sides, things like that, okay? So the object should look very similar, actually congruent, just in a different location, okay? To do a rotation, we need to know three things. The center, all right, the center of rotation. In this image right here, we have image P being the center of rotation. And the direction in this situation looks like from A to A prime, we went clockwise, the way of a clock, around P. All right, as did every other point or vertice on the existing uh, figure. And the angle. In this situation, that's a 90-degree angle. And this situation over here, it's a 120-degree angle. But notice the distance between the center of rotation in this image for each vertice stays the same. F, for example, to C is two triangles of length, as is from F prime to C, two triangles in length as well. And it's the same with both G and E, and G prime and E prime. All right, so just remember, to rotate, you need the center of rotation, the direction, that's clockwise or counterclockwise, and the angle, all right, of how many degrees you're going to rotate. Okay, that's it. Have a beautiful day.